of trimester number 1. And man, oh man, Lord willing, if we get to this, boy, pre-calc does not want you leaving first trimester without a big impression left with you, because now they're going to focus on a couple applications of vectors. Now, there's a lot going on here, and I've never even seen this stuff before. This is my first time seeing it, so I hope I can explain it well. Here we go. Even if I don't explain it perfectly, I'm going to tell you how I look at it, and we could have a nice discussion, argument, whatever. So all you professional vector physics people out there, forgive me if I'm not perfect in my explanation, but this is best I got. So here's the math problem. Bob and Sam are on a chairlift, so you can see there's like a big old support right here, and it's going up the mountain. There's a bigger support, so you can see that the chairlift's supposed to be going up and up and up. And so it says the chairlift breaks. Now, together they weigh 402 pounds. So let's start with a really easy, low-hanging fruit question. What is the component form of the weight? Well, I made this little dot blue. That's kind of like your origin. That's the center of the mass, the problem. So, and their weight is 402 pounds going down, so it's the same thing as 402. Remember, direction and force. So what's the magnitude? Zero, or excuse me, component form? 0, negative 402. Because that is down, okay? So, that's this vector, straight down, gravity. Okay, that's their total weight. Now get ready for this, because this is crazy. This is connected to this, which is connected to this. So, this is a directional angle formula for vectors. So, what we have is any vector can be written like this. So, what do you notice? You notice we got vector u right here, and let's talk about it. Well, if this is 12 degrees, then that vector was spun. Let's make sure we don't screw this up. Vector u is the magnitude, and that's what they're asking for. How many pounds of force are on each? So they're really asking for the magnitude, which is hidden in the formula right there. So I'm focusing on this vector, the red one, and I'm going to fill in what I know. So I don't know the magnitude of v, that's what we're trying to find. Cosine of the direction angle, which we said was 168. Is that right? Yeah, because that plus 12 is 180. So 168, comma, magnitude of, well, this should be u, because we're talking about the vector u, so don't let me mess you up there. And this is u, and then it's sine 168 degrees. Okay, so that's vector u. Now let's talk about vector v. All right, it's the longer one. Now what's the directional angle there? Well, that's just 32. So let's fill in the parts. Magnitude of v, cosine of 32, magnitude of v, sine of 32. Now here's where physics is going to come in. And this is, it took me a while to kind of figure this out, wrap my brain around it. But in the world of physics, there's this formula, and it's kind of, or an idea called state of equilibrium. So before poor old Sam and Bob fell, they were at a state of equilibrium where there was stress on the cables. Now the state of equilibrium is when the x values, because that's what that is in component form, so we've got this value and this value are just hanging there, and they're canceling each other out in essence. So if I took this is my A1, and this is my A2, and I took both of them, and I said the magnitude of u, cosine 168 plus this value, so magnitude of v, cosine of 32. State of equilibrium would be 0. There's a tension there, and it's just sitting still. And that's a concept I never heard of before I was introduced to this particular problem. But that's not all we have going on. We're going to use this weight as well. So what we have is the y value in each of these. That's the up and down force. So this value plus this is going to result in a 402 pound situation. That's the magnitude of that particular vector. So then we have this right here, the magnitude of u, sine of 168, plus this value, the magnitude of v, sine of 32, has to equal the resulting weight of 402 pounds. Now, crazy, we have a system of equations. So what I'm going to do is I'm going to erase the actual problem's words because I need a lot of space to show you some crazy math now. You're going to see a system of equations like you've never seen it before. So just for simplicity, I'm going to call that x, and I'm going to call that y. So this is my x and that's my y, because that's how my brain likes to work. Now watch what I'm going to do. I'm going to go, clear this out, cosine of 168, enter. So I get negative 0.978x. Let's just call that negative 0.98x. Okay. Plus, excuse me, let's keep going. Plus cosine of 32, enter. That's 0.848, let's call it plus 0.85 y equals 0. Now we're going to clean this up. So sine of 168, enter. I'm going to call that 0.21 x, and then sine of 32, enter, 0.53 we'll call it, 0.53, and we called that our y. And notice we have a crazy looking system of equation. Now let me pause this a second. Okay, I just want to double check my work, make sure I didn't really screw this up. So you guys have never seen, I don't think, a system of equations like this. I'm going to attack my x values, and I'm going to multiply this by 0.98, and I'm going to multiply this by 0.21. You can see I'm trying to cancel out the x's. Now I'm going to hit pause a second again. Okay, I didn't want to completely bore you with my math, but in the process of hitting pause, I noticed I made a mistake. 402 was supposed to come along right here. Maybe some of you picked up on that. So I distributed, and that's what I got. Distributed, and that's what I got. Notice, if I add these together, my x's go bye-bye. Add those together, it actually works out pretty good. 0.70, or just 0.7, equals 393.96. Now, this is y. So I got to divide by 0.7, divide by 0.7. So divide by 0.7, and I get y is 562.8 pounds. That's the magnitude we assigned v. So we went to our drawing. There is 562.8 pounds of stress on that cable. Now they want the magnitude of each of them, so we're going to have to plug it into whichever one we think is easy. So I'm going to go with negative 0.98x plus 0.85y equals 0. There's just a little less going on. So if y is 562.8, I'm going to put it right here. 562.8 equals 0. I'm going to multiply that, 0.85, and then bring it over. So it'd be negative 478.5 4 equals negative 0.98x. Divide 0.98. And I get 488.1. So this vector is 488.1 pounds of weight on that shorter cable. Amazing math problem. I'm going to give you one of those for your homework to work on. So good luck on that. All right, so a completely different thing in relationship to what I just showed you with the poor dudes on the chairlift. First of all, this is going to be how to talk, vector talk, especially in relationship to flying, and pilots use this sort of a language. And here we go. So we're talking about quadrant 1, and we've got an airplane going that direction. If your perspective is from this east component, you would say that this airplane is north of east. So where you start is so important, because that's what you're going to say last. Because what if another person's perspective is here? You would then say you are east of north. You're on the east side of your northern boundary. Okay? Let's go to quadrant 2. Let's go from this perspective first. So we're starting from the west. So what is this? Well, we're heading in the north direction, so we would say north of west if we're looking at that red. But if someone else's perspective is here, we start here. This would be west of north. West of north. Hopefully you're kind of picking up on this. Let's go to quadrant 3. What if the person's perspective is from the west? Where are you going? Well, you are, in that situation right there, you are south of west. I'm abbreviating. What if your perspective was there? Well, that would be west of south. Starts making sense after you use it a little bit. Quadrant 4. Let's go from here. What's that? Well, that's south of east. What if I started from that direction? That'd be east of south. Abbreviating. That sets the table for your final problem of trimester A, and it is a doozy. It's got geometry, trig, and vectors, everything. So you can tell I'm a little fired up. But that's going to have to be a new video. Kind of running out of time on this one, so.